The story told in the exhibition begins at a time when few dyers were chemists, and almost all colors were extracted from living organisms, and ends at a time when dyes were synthesized in laboratories. A Berlin color maker named Disbach accidentally stumbled upon what came to be called Prussian blue, a new source of blue, in 1704. Disbach was trying to make cochineal red lake a dye-based pigment for painters. The solution that he produced was extremely pale. In an effort to salvage the result, he attempted to concentrate it. In the process, his solution changed to purple and then blue, forming a compound that chemists call ferric ferrocyanine. The two new sources of yellow were discovered in the 1770s. The first was the American Edward Bancroft's 1775 discovery of coeur citron, a vegetable dye extracted from a black oak found in northeastern United States and southeastern Canada. It was brighter, more stable, and cheaper than traditional sources of yellow, and became extremely fashionable in the late 18th century. The second was Peter Wolff's 1777 picric acid. Unfortunately, this Irish chemist's organic compound, made by treating phenol with nitric acid, was not manufactured until the 1840s, after a method for making phenol from coal tar was developed. The discoveries of new shades of yellow, combined with the ability to bleach commercially, also led to the fashion for new shades of beige. The term grège and beige can describe the lack of color in unbleached textiles. The dull or faded appearance of textiles, ranging from a light olive brown to gray color, can be called drab. Until the mid-19th century, red dyes were extracted from insects such as cochineal and kermes, or from such plants as madder and Brazil wood. Prices varied depending on their solidity, depth, and origin. Kermes, for which the word crimson derives its name, was indigenous to Europe and was among the most expensive animal-based dyes of ancient times. If red was one of the most desirable colors that was sought by the rich and powerful, guess which dye was the first to be examined in the laboratory? Among the earliest discoveries that would initiate the progressively artificial ways to process natural dyestuff was the isolation in 1820 or 1827 of alizarin, the compound in the madder root that produces the color red, by the French chemist Pierre-Jean Robiquet. As luck would have it, it was an 18-year-old working in his parents' garden shed that would soon stumble across a reddish-brown sludge extracted from a coal tar product that would cause the purple fashion phenomenon. Purple had always been a majestic color since ancient times. The well-guarded secret of Tyrian or imperial purple was a well-guarded secret. The dye was extracted from two species of Mediterranean mollusks. 1 ounce of dye required the use of 250,000 shellfish, which made it incredibly expensive to produce. The secret for making purple dye from mollusks was lost to the Western world with the fall of the Byzantine Empire in 1453. There were some plants that could produce purplish dyes, but they did not resist sunlight or washing very well. William Perkin was a gifted young student of August Wilhelm Hofmann, the first director of the Royal College of Chemistry in London, where, starting in 1845, many young pupils were mentored in the mysteries of coal tar hydrocarbons. Unlike Colbert, Perkin saw potential in the reddish-brown sludge he obtained while attempting to produce synthetic quinine at Hofmann's suggestion. In 1856, the Perkin family launched a factory which had to compete with other producers of semi-synthetic purple dyes, Murexine and French purple. Murexine was discovered a few years earlier in 1853 by Frederick Sachs and Alexander Schrumberger. It was obtained from Peruvian guano, a substance consisting of solidified bird droppings. Beginning in 1856, French purple was processed from lichens. Despite its abundance in nature, obtaining a deep and lasting green hue on cloth was usually a compound process. Using only natural dyes, dyers would first dip the cloth in a yellow dye bath. The yellow dye was usually old fustic, extracted from the woad of a tree of the Mauritian family. Then the cloth was dipped in a blue dye bath of indigo, and this resulted in Saxon green. It could be reversed with a blue bath first. This long-established tradition continued despite the introduction of new dyes and processes. Vert de Chine local, the first one-step vegetable green dye, was obtained from a Chinese shrub and introduced to Europe in 1852 or 1857. In 1859, a new green drawn from a mineral sort, vert d'Imet, was produced in the laboratory using boric acid and potential dischromate. This innovation was a much safer alternative to arsenic greens. At the eve of World War I, Germany controlled 80% of the world's chemical market, which strengthened the country's economy considerably.